The 100-watt charger plugged into your phone right now is not delivering 100 watts. So who decides what it does deliver? Now take the cable out of your drawer, the one that came with something else, same connector. It clicks into the 100-watt brick. It clicks into your laptop. The laptop starts charging. It's charging at 60. Nothing warns you. I've always been curious about the power ratings on chargers, like 20 watts, 65 watts, 100 watts, or 140 watts. What do these numbers really mean? Are they actually charging my device at that speed, at that voltage? I recall buying a cable and being shown its power output, which was significantly lower than what my charger claimed. This experience taught me that a 100-watt charger isn't always charging at 100 watts, and a 45-watt charger doesn't always operate at 45 watts. These numbers represent a maximum threshold, not the actual power output, which rarely reaches that level. Plug in USB-C, and the charger doesn't push anything past 5 volts. Every connection starts there, and the connector spec forbids a single word of negotiation until the line has actually reached it. Then they talk, over one thin wire inside the connector, in a language called power delivery. The charger sends a menu of what it can offer. The phone picks one line off that menu and asks for it. The group that writes the USB standard puts it plainly. Each device takes only the power it requires, and if a device refuses to negotiate at all, a spec-compliant Type-C port tops out at 15 watts, 5 volts, 3 amps, advertised by nothing more than a resistor on that same pin. No conversation, no high voltage. That ceiling belongs to the standard. A charger and a device that share a protocol of their own can go past it. Power delivery ties the number on the box to a fixed set of voltages: 5, 9, 15, 20. The power specifications table says what a 100-watt port must offer at each rung. At 5 volts, it must offer 3 amps. That is 15 watts. The full 100 lives only on the 20-volt rung at 5 amps. Now read the title of that table, minimum currents, not maximums. And the spec's own rule says a source may offer more than the table asks at a given rung. What the standard never does is require it. So the label is not a flat guarantee across the ladder, it is one corner of a table. The phone isn't the only thing the charger talks to. Over that same wire, it interrogates the cable. A plain USB-C cable is a 3-amp part. Anything rated above 3 amps has to carry a chip inside the plug. That chip reports the cable's rating when it's asked. No chip, and it stays a 3-amp part. The power specification is blunt about what follows. Above 60 watts requires a 5-amp cable. 20 volts times 3 amps is 60 watts. Your 100-watt charger just became a 60-watt charger. Push past 100 watts and the bar rises again. USB Power Delivery 3.1, announced in May 2021, added 3 new fixed voltages: 28, 36, and 48. They reach 140, 180, and 240 watts. Before that, the ceiling was 100, 20 volts at 5 amps. One of the things those higher voltages need is a cable rated to 50 volts. Sometimes the cable's identity is the whole gate. Apple's 16-inch MacBook Pro from 2021 through October 2023 fast charges from the 140-watt adapter only through the MagSafe cable. November 2023, models onward can also do it over a 240-watt rated USB-C cable. That is Apple's documented gate, not a rule the standard imposes. There is one power supply inside a multi-port charger. How it carves that supply up is the manufacturer's published policy, not a property of the label and not something the standard decides. So this has to be said per product. Anker documents its 140-watt 4-port charger precisely. 140 watts on one high-power port, used alone. Occupy both high-power ports and it recuts to 70 and 70. Its low-power pair gets 24 watts total. There's a printed priority order too, running from the first port down to the USB-A. Their 3-port model does something sharper. 2 devices open the session at 45 watts and 22.5. If the lower port never establishes a charging protocol, the charger waits 1 minute. Anker's test for that is under 6 volts and under 1 amp. Then it recuts to 60 and 5 and hands the power to the device that actually asked. Now the far end of the chain, a lithium-ion cell doesn't charge in one steady gulp. The chip that does it inside the phone names 4 stages: pre-charge, constant current, constant voltage, termination. Only one of them draws peak power. Constant current, the current stays flat while the cell's voltage climbs. That is the only window where peak wattage exists. Then constant voltage. The voltage holds and the current tapers continuously down toward a termination threshold. Power falls the whole way down. So charges at 100 watts really means briefly touches 100 watts. The last stretch of a full charge happens at a small fraction of peak. Programmable power supply. It's the mode Google specifies for the fastest pixel charging. Any such adapter rated 30 watts or more. 30 is the floor on that list, not the top of it. The biggest charger Google sells for the phone is 67 watts. Instead of picking a fixed rung on that ladder, the phone requests a voltage in 20 millivolt steps and a current ceiling in 50 milliamp steps. Then it asks again and again as the cells fill. Each adjustment is a discrete message, not a continuous dial. The phone resends a request every time it wants a new operating point. On a full-range controller, that adjustable span runs from 3.3 volts up to 21. So the phone isn't just taking a rung the charger offers, it's steering the charger inside that span, notch by notch, toward what its own cells will take right now, not toward the charger's maximum. The number on the box is watts out of the port, not watts into a battery. On the wall side, US efficiency rules put a floor under it. Take a single-port charger rated above 49 watts and up to 250, driving its one output at high voltage. It must average at least 88% in active mode. Though the table has no line naming a USB-C charger, that 88 is the class this one gets sorted into, not a rule written for it. So the socket always gives up more than the port delivers. Then the cable. The connector specification permits 3/4 of a volt lost across it at rated current. At 5 amps, that is 3 3/4 watts, turned into heat inside your cable. Legally, and the 20 volts isn't 20. A fixed voltage is held to within 5%, so 19 to 21 at the charger's own socket. Then inside the phone, one charge pump charger chip is specified at 98.6%. Peak at one favorable operating point. Every stage here is small. Don't multiply them into a single number. Nobody publishes the honest total. So the 100 was never a delivery figure. It's the top rung of a ladder, and 4 separate parties have to agree before anything reaches it. The phone, the cable, the port you happen to pick, and the chemistry of a battery that only wants peak power for a fraction of the session. Disagree on any one of them and nothing fails. The chain just settles, quietly, on the largest number every part of it can survive. That is the whole trick of a connector that fits everything. Everything in it has to be declared, so nothing in it ever has to be trusted.